Hello everyone, in this video we're going to do a rundown of the distributive property and combining like terms. So right here I've written out the rule for the distributive property, and what it's telling us is this. In a set of parentheses we'll separate terms with addition or subtraction. You may have more than two terms on occasion, but this is just the fundamental setup. We'll have real numbers A, B, and C. In this case, one of those will be on the outside of these parentheses, and all we do is multiply that outside term to whatever is inside those parentheses. Doesn't matter if those terms are separated by addition or subtraction, we'll get a combination of a lot of different terms. And if we're able to combine any together, it makes for a nice answer. And again, this works for every real number. Let's take a look at a few examples. Over here, I've got 2 times the quantity of 5x plus 3. We'll work out this one first. We're going to distribute the 2 to the terms here in parentheses. So that'll be 2 times 5x. And this will be added to the product of 2 and 3. This product here gives me 10x, and this product here gives me 6. This is our final answer, and we can go on to the next one here. The nice thing about this problem, and what's interesting about it, is that we're going to be using that multiplication property of -1 that I did in a previous video. So what we're doing here is we're distributing -1. So both of these terms are separated by addition. They're both positive. Once we're done distributing, both those terms are going to be negative because we're distributing that -1 to every term in the parentheses here. I'm just writing out the multiplication steps here. So now we've got -6x minus 4. This would be our final answer right here. So let's talk briefly about combining like terms. So like terms have exactly the same variable factors. So we talked about variables a little while ago. If I had 2x, 6x, 17x, and -16, just to change it up a bit, -16x. These are all like terms because they share the same variable factors. They all share that same variable value of, or the same variable x. The numbers in front of those variables, those are known as coefficients. So 2, 6, 17, and -16, these are all referred to as coefficients. They're the numerical factor of the term, just the number in front of the variable here. So what would be examples of other like terms? -5x squared and 18x squared, because both of these terms share that same x squared variable. Examples of some things that are not like terms: 8x, 7y, 2 different variables. Another example would be x squared y and xy squared. These are not like terms because the squared exponent here is different for each variable. Here x is squared, y is not. Here y is squared and x is not. So these are not like terms. Not like terms. Whenever we're done distributing, if we're able to combine any like terms together, it makes the answer look a lot nicer. All we're doing in distributive property is expanding on what is being multiplied together. And we're using distributive property very often in algebra. So it's not going anywhere, it's going to stick around for quite a while. Thank you so much for watching, and I will see you later.